This is Joseph Alexander Van Zandt. Today, I will be discussing summation, specifically summation by Euler's method. Euler was a mathematician associated with the Etruscans. The Etruscans were the ones who built much of what you see in the city-state of Rome, the Colosseum and the amphitheaters and those things. There were recent archaeological finds in Herculaneum and Pompeii, which confirmed that. Among the things they found were mathematics related to Euler, or said to be written by Euler, about adding sums in sequences, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Euler developed a very simple way of adding numbers and sums that makes it very easy for people to do it and for computers to do it as well. Computers, are capable of adding numbers just straightforward. But if they use Euler's method, it's much easier for computers to do it. It's much easier for people to do it, but it's also much easier for computers to do it. If a computer uses Euler's method, it can do calculations it can't do otherwise. In any case, I will explain, in writing, and there's a computer program that I wrote which also does it, which uses Euler's method, and there's a graphics calculator I have that will confirm my calculations. Seeing is believing. So we'll start with the first 10 counting numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you count those numbers, and I have them here at the top, and then you go the other way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If you add them each, you get 11. 1 plus 10 is 11. 2 plus 9 is 11. 8 plus 3 is 11. 7 plus 4 is 11. 5 plus 6 is 11. 6 plus 5 is 11. You get 11 10 times. So if you have 11 times 10, you get 110. If you times something by 10, you just add a 0. Okay, correct. So you have 11 times 10, which is 110. Then you divide by 2, and you get 55. 55 is the correct answer in this case. I have here a graphics calculator, and I will do the calculations here. I have them done on top, but I'll do them again. The graphics calculator comes up with 55, which confirms my calculations. The first 10 counting numbers added is 55. This is called summation. The second example I would use is 1, 2, 3, 4, 5. And then I will go the other way. 5, 4, 3, 2, 1. If you add, you get 6. 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. 2 plus 4 is 6. 5 plus 1 is 6. You get 6 5 times. Okay, and then you take 6 times 5 and you get 30. 30 times divided by 2 is 15. And I will confirm this with a graphics calculator. 1 plus 2 plus 3 plus 4 plus 5. And it's 15, which is the answer I get here. If you were to do this without using, this method called Euler's method, it would be a much more difficult enterprise. This is another example. This is 10, 11, 12, 13, 14, 15. And I'll go the opposite way. 10, 11, 12, 13, 14, 15. 15, 14, 13, 12, 11, 10. So if you add each, you get 25. 10 plus 15, 25, 11, 14, 25. 12 plus 13, 25, 10. You get 25 6 times. So 25 6 times is 150. Divided by 2 is 75. I'll use the graphics calculator here to confirm. Okay, 10 plus 11 plus 12 plus 13 plus 14 plus 15 divided by 2. Correct. So you get 75, which is the answer I get here. The final one I will do is 1, 2, 3, 2, 3, 1. you get 4 each time. You get 4 3 times. So 4 times 3 is 12. 12 divided 2 is 6. I'll do it here with the calculator again. 1 plus 2 plus 3 and 6, which is the answer I get. On the computer, I'll do these two. Turn this on here. Okay, this is the program here. Okay, so it's asking me to show me around here. This is the computer which I have here, which has the program. You'll start with the first is 1, the second is 10. It comes up with 55, which is the correct answer. But this also works with virtually any number. You could come up with a number, let's say 1 is the first number. The second number we're going to have is 55,000. Okay, so 55 ones, tens, hundreds, thousands, 10,000s. Okay, let's see what it says. Okay, it did the answer. The computer says 1. In other words, if you add 1 plus 2 plus 3 plus 4 all the way to 55,000, the number you have here is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you have 10 digits, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. So it would be 151 million. 151 million, 252,000. 7,500. Okay, is the answer the computer comes up with. Okay, that's an example of summation with Euler's number. Euler's number really, in terms of computers, it can be used as a logarithm or a method of calculating numbers, which is much easier. If you were to do this with adding, I believe that the computer could do it, but it would take much more time. This did it almost instantaneously because it's using Euler's method. Euler's method is a very easy way for people to add numbers, and for computers to add numbers if you understand the dogma of how to add. This is Joseph Alexander Van Zandt. Thank you for listening.